Hi there, this is Jacob Nash Algebra Lessons, and this is Unit 4, Lesson 13. That's the date, actually, when I'm making this video. If you see up there, like in that corner, Tuesday, April 13th. Nothing bad has happened to me yet, because sometimes bad things happen on that day. There was like a tornado that almost ruined my house last time, in 2020. But anyways, so this is on division, how to divide polynomials. There's 3 ways that I've written here, and pretty much the first one's easy. Well, actually, it gets more and more complicated of each one, and you can't choose, unlike factoring. Well, you can't really choose for that anyways, but like how in quadratics you could do quadratic formula, completing the square, factoring, whatever you want to do to find zeros. To divide polynomials, there are 3 ways, but they're for specific situations. So the first one, I just call it monomial and denominator. Remember, monomial is just something like 3x or something. Where there's just one term, not like plus something, minus something. No. So that's what that is. That one's just simple. All you have to do for that one is you divide the coefficients and you subtract the exponents. I'll show you what that is in a minute. Then the second one is long division. You need to do that one if there's not a monomial in the denominator. Well, technically, I guess you could do the long division one any time you want, I guess, pretty much. But the third one is synthetic, and that one you can only do if the thing on the denominator it can be a binomial. Well, actually, it has to be binomial, and it has to have, the first term has to have, it basically has to be, the first term is x to the power of 1. It has to be that, plus or minus something that's a constant with no variable on it. So, for example, it could be x minus 9 or something. But it couldn't be 2x minus 9, and it couldn't be like x minus x or something. Well, anyways, that would cancel, but we'll look at that. So you might want to pay attention because there's certain steps you have to do in them. But the first one is not very hard. So let's look at an example. Let's say we have 8x squared minus 4x plus 2. And let's just say that's divided by 2x. What do we do? Well, we have to divide each of the parts of the top. So here, there's 3 parts, the 8x squared, the minus 4x, and then the plus 2. That's the 3 parts. We have to divide them all by the one thing, 2x. So remember, we divide. It's the opposite of the multiplication one. You divide coefficients, and then you subtract exponents. So, for this first part, 8 divided by 2 is 4, and then we have x squared minus x, divided by x, which pretty much has a power of 1. So, you do 2 minus 1, which is just 1, so just x. For this part, you do 4 divided by 2, negative 4 divided by 2 is negative 2, and then x is, well, you would already know that they cancel, but that's just because you have x to the first, x to the first. Since you subtract them, 1 minus 1 is 0, so that's why there's nothing now. And then here, you can't do anything because there's no x on the top, but these can turn into 1s since they're both 2's, because 2 divided by 2 is 1, but you still have a 1 on the top, and it's going to be plus 1, and they pretty much cancel out, and then you have x on the bottom. So that is what that would be divided. 4x minus 2 plus 1 over x. So that's how you do that. That's pretty simple. That's only if there's a monomial, remember, in the denominator. Long division, that's if there's something different. So let's say we have 3x squared plus 7x minus 12 divided by x plus 3. How about that? Okay, so what do? Well, we see that there's not a monomial in the bottom, so we know that we can't do method 1. But what you have to do is you have a kind of like division sign. Don't mistake that for a square root. You know, sometimes, like, in elementary school, instead of having, like... Okay, that's bad. Okay, let's see if I can get the way it was. Okay. In elementary school, you would sometimes have... You wouldn't have, like, 49 divided by 7 like that. You would have, like, 49 divided by 7, whatever there is. But anyways, we have... You put the denominator over here, and you put the numerator in the thing, in the symbol. So that's what we have now. What do you do next? Well, next you have to figure out what the first term could multiply by to equal the same thing as the first term in the part that's under the sign. So, in other words, what could x multiply to equal 3x squared? Well, 3x. Because 3 times 1, which is, there's pretty much a 1 on there, that's 3. And then x times x is x squared, so that's what we would have. So, what we do is we put that 3x up here for now, and we just put a 3x squared right here, because we know when that multiplies by that, we get that. Next, we have to multiply the second part of this by what you just found. So, we have plus 9x. That's all we're doing so far. So, in other words, the first steps are just to put the denominator right there, numerator in there, then figure out what this can multiply to equal that. It's not going to be the same, obviously, but just the first terms of both things, what can multiply to equal each other. Then you put whatever that answer is up there, you put the same thing here, right here, and then you multiply these two things together and put that there. That's what you do. I mean, I know that's a lot of there's, that's, but there's not specific words you can say for that. But now what you have to do is you have to subtract both of these. So you basically just kind of ignore the plus signs here and just act like there was minuses. So the purpose of doing that was to cancel that out, and then we have 7 minus 9, which is negative 2x. And then we bring down this negative 12 right here. Now we need to do the same thing. What can x multiply to equal that? This time it's going to be minus 2. We put that up there, put the same thing right here, and then multiply these together. That's going to be negative 6. And then, once again, you change the signs. So now we have pluses here, and just ignore the negative signs. You don't ignore those signs, but, anyways, so you have, these cancel out, once again, that's why we do this, so those can cancel out, and then we have 12 plus 6, that's negative 6. This is what is your remainder. So that means that this cannot divide evenly, which is basically why we had to do that in the first place. So we take this up here, and we do, our answer is going to be 3x minus 2, and then we have minus 6, but since it's a remainder, we have to make it divided by this, x plus 3. So that was a long process. That's what our answer is, but you might want to rewind to just see all the steps that I did. I wish I could tell you, like, specific steps, but it's not very easy to say in, like, words. But you basically just have to remember the process. It's just you're trying to multiply something, then you subtract or add things, and then if you get a remainder, if those happen to cancel out, then there would be no remainder, and it would just be this. But since there is a remainder, you do that. So that's long division. If you think that's hard and complicated, then you're really going to think this next one is. But to me, this one's like a little bit simpler, kind of. I mean, like, it's long, but you're doing the same thing over and over. So this is called synthetic division. And like I told you earlier, you can only use this if in the denominator it's like something x by itself that can't have an exponent other than 1, and it can't have a coefficient other than 1. X, and it can be plus or minus anything, but there just has to be a number here. So that's what the denominator has to look like. So one example of how we could use that is this. We pretty much could have used synthetic division on the last one. So how about we do 2x to the fourth minus 12x squared plus 26x minus 24 divided by, how about x minus 9. So here's what you do. You first need to draw like a little like angle thing and then a line like this. So that might look weird, but here's what we're going to do. You have to put something right here, and you have to put things right here. But what things do you put? Well, what you put right here is you take this, you set it equal to 0, and you figure out what it would be. Obviously, x equals 9. So you put 9 here. Simple enough. Now, what you put here is just the coefficients of all of the things here. So we have 2, negative 12, 26, negative 24. So we put those 4 numbers here, probably with a little space so you don't get mixed up. So how about 2, negative 12, 26, negative 24. Okay. Now what do? You bring this first number down and you just put it below this line right here. So we have 2. Now what do? Well, we're going to do a constant process of adding and multiplying. So we do multiply, add, multiply, add, multiply, add until we're done. What we do is you see what number is here, whatever number is below the line, you multiply by what's in the corner, and then you, whatever that is, you put here, and that's what it would be, 18, and then you add it by the next thing, and then we'll see how it is. So we're doing 9 times 2, we get 18. Okay, so we put that there. So remember, we multiply first. Now we're adding. We add these two things. Negative 12 plus 18 would be 6. Wait a second, did I just do something wrong here? Oh, no, I didn't do something wrong. I don't know what I was thinking. Okay, there's 6. Now, since we have another number down here, multiply. Once again, 54, that's what we get. So then, now we have 26 plus 54, which is 80. Then you have 9 times 80, which would give us 720. Or wait, we don't put that there, we put that here. And then negative 24 plus 720 would be 696. Okay, that seems a little weird. But this tells us a lot. So, well, since we didn't get 0 right here, that means that there is a remainder of 696, which that's not so good, but whatever. That I just made up these numbers, so it turned out to be something kind of not so good. Oh, I'm sorry, I messed up. I knew I was doing something wrong. Okay, so notice how the exponents here are 4, 2, 1, because there's nothing there, and pretty much 0, because there's no x. You have to put something here for a 3, and since there was nothing there, we had to put a 0. So that, I did it wrong, so let's try that again. Sorry to have to do this whole long thing again, but I'll do it quick now that you know the idea of what you're doing. Okay, so we have, bring the 2 down here, 9 times 2, 18, 0 plus 18, 18, 9 times 18, we have 162, right there. Then we have negative 12 plus 162, we have 150. We have 9 times 150. See, we're getting even bigger numbers now. 1350. 26 plus 1350 is 1376. Ooh, 9 times 1376. And then we get, oh my gosh, I'm going to have to bring that up. Down here, we get 12,100 or 384. Negative 24 plus 12,384. 12,360. All right. There we go. So that's actually our remainder, not 696, 12,360. So that's a big remainder. So obviously that means that x minus 9 is not a factor of this polynomial. Not something that can multiply to equal it evenly by factoring. So that good, we have a number now, but how do we make our answer? Well, we take these three numbers here, or sorry, actually these four numbers here, and we just sit them aside. All right, we have them here, and then we have this number 2. We basically just take the 5 numbers that are down here. This one would be over here, but I ran out of room. That's why it's like that. So we have those. Since this was the remainder, we put it over x minus 9. Now what do we do? You need to add x's to these, but they all ended up being positive, so we'll just add pluses. Now we need to add x's, and the exponents that we put on there are going to be 1 less than how it was when what's on the top. So 1 less than 4 is 3. 1 less than 2 is 1, so nothing. 1 less than... Wait a second. Oh, I might have done something wrong even again. Hang on, I gotta look at something here real quick. Might want to skip the video for a second. Oh, yeah, well, now sorry. So you don't do it 1 less necessarily. You start with 1 less than what it was. So that's 3. But then you just make the exponents lower and lower. So we have, when there's 1, there's pretty much nothing there that you need to write. And when it's 0, there's no x at all. So this would be our answer. 2x cubed plus 18x squared plus 150x plus 1376 plus 12,360 divided by x minus 9. There you go. That is not such a good answer, but that's how it has to be. So to review, when you're using synthetic, you have to set this equal to 0, put whatever that answer is there. You put all the coefficients here, then you bring the first one down, multiply, put that answer there, add, same thing, multiply until you get to the end, and then you take all the numbers that are on the bottom, you add x's to them, and then add powers to them based on what was there. You start out with 1 less than the first exponent on the first term of the numerator of the original problem that you're given. Then you go lower, lower, lower. Remember, if there's x to 0, just take away the x. And then when there's a remainder, you put it divided by what their numerator or denominator was in the first place. So that's what you do, and that is how you divide polynomials. Definitely harder than the other ones, but you just have to remember the process. So thanks for watching, and I'll see you on the next video.